Perfect. All right, so I think I just saw Tim leave the room. I guess I get the fortunate pleasure of starting right after a break, and so my joke that I was going to start off with was you go outside, didn't realize this was a vampire conference, right? So we're all indoors, there's LED lights up here now, but you go outside, you get blinded, and then there was the comment made that this event could be sponsored by Hair Club for Men because of all the balding guys. So I appreciate Sam showing his pictures from before where he had longer hair. I just wanted to show I had shorter hair and now it's getting longer. So I'm going to tie this into my talk though. So I'm talking about IPv6 and I'll get into some other stuff, but the whole idea here with IPv4 versus IPv6 is this mentality of scarcity or lack of hair, and then now we've come into abundance. Marcus, one of my coworkers in the back, was asking the question, didn't you talk about this 5 years ago at WLPC in Dallas? We talked about IPv6 and kind of a similar topic, and I'm still not really running into it anywhere. So what's the deal? Show of hands, how many people in the room are running IPv6 on their network today? A bit more than I thought. So keep your hands up. How many of you with hands up are in higher ed? Pretty much the same set of hands. I think I lost 3. So, good kind of discussion. IPv6, and if you, what happened here? And if you look at your phone or your laptop connected to the network right now, there is no IPv6 in this network. And we can go further. I've got a screenshot from an iPhone. A lot of the questions come up where I just don't see that IPv6 is really a big deal. If you dig into another set of tools, I can actually show on my iPhone that I've got quite a few IPv6 addresses. So V6 is in use, it's just where is it in use? And then what does that mean to us from a wireless perspective? I did this talk, like I mentioned, 5 years ago. I'm also covering it in Atmosphere this year. But really with IPv6, it's the joke I made 5 years ago is what's old is new again. So how many people ran, Amy makes fun of me, my original tablet was a stone tablet and we carved on it instead of an iPad. How many people ran Novell NetWare in their networks? Okay, so a lot of people familiar with IPv6, with IPX. I would say that IPX and IPv6 seem very similar. There's some commonalities between them. But the whole goal is really getting us behind. IPv4 did a lot of good things for us. IPv6 is the next wave, and we're starting to see that we're running out of addresses in different places. It seems like it's new technology. My next slide will kind of show that it really isn't so new. But we're trying to solve a couple of different things, and the biggest thing being just the sheer number of addresses. And when we start looking at things like IoT, Tom yesterday mentioned industrial IoT, we start getting a lot of different sensors, home automation type stuff. There are a lot of things that are continuing to be on the network that we need to support. They need to have addresses. And man, wouldn't it be nice to not have to sit down with Brad Floyd and go, well, what size subnet do I need to have on that guest network at my university? If they just all worked and made addressing easier. So some quick things about what is IPv6. The biggest thing is it's 128-bit address space, and there's a lot of addresses. It sounds like a lot of addresses. I meant to reach out to Keith earlier. We were going to have in the giveaway bags, everybody gets a free IPv6 address. So you get one, take it home, use it however you'd like. It's good stuff. There's new packet formats. There's simplified address assignment, and we'll talk through that a little bit. And the big thing that I hyped on 5 years ago was there's no broadcast. So we don't have to worry about broadcast frames going across my wireless, right? We might be multi-protocol for a little while, but broadcasts are gone, and we've replaced them with some really cool stuff you've not heard of unless you were here yesterday when we talked about multicast. So kind of how did we get here? I also like Sam's conversation earlier about kind of timeline on some stuff. I first started working with IPv6 back in '98. There was, seems like that was also the same year I started working in wireless. There was a company that was wanting to do some multi-tenant. We're going to do IPTV in your apartment complex, and so they were looking at things and wanted to do it all over IP multicast. But IGMP just wasn't fast enough for me to have an IP set-top box. And as I'm channel surfing, I couldn't do the IGMP joins and leaves fast enough to not flood my 10 meg link with all the multicast streams coming in. So they started looking at IPv6, and we did a little digging in there. And that led me to get into having a 6-bone connection and doing some more testing and those kind of things. And it's been interesting to see how this has evolved. But there's this mentality that IPv6 is somehow new, when in fact it comes out from 1992, which some people would think that's really old, and I was out of college by then. But it's gone through several different iterations, and so some of that you'll see some different address terminology or different standards that have been used that are already deprecated. And so just wanted to kind of cover off some of the points that we want to know about from a wireless perspective and kind of go from there. The interesting thing, I think, is we have more international attendees here than probably the first year that we were in Austin. A lot of the IPv6 drive really is coming from more of the international market. So a lot of the rears that do all the IP address allocation and assignments, as we started to get close to running out of IPv4 address space, they adopted different standards on how we were going to do this graceful exhaustion. Aaron, for North America, decided just let them take it all, and when we crash, it'll all be good. And so there's been a whole lot of reverse engineering or engineering new things. How can we do more with NAT and make sure we're using RFC 1918 space? A lot of things to lessen the impact of this IPv4 exhaustion, but we are seeing it a lot more when you get into Asia and some South American areas where IPv6 is having a stronger play. We see it a lot more in higher ed because of the research implications, those kind of things, and going from there. So just kind of quick slide to show the ramp on IPv6 adoption. And again, it's really as we run out of these address ranges, then we've got to go somewhere. And from a lot of the perspective, it's looking at a carrier or my ISP or whoever's giving me my internet connection. If I'm not doing V6 today, I'm expecting that somebody else is going to handle this IPv6 translation if I'm trying to get to a site that is only available via IPv6, or if I'm trying to allow clients who are only IPv6 connected to come back to me, somebody has to do that translation. And so the opportunity is either I let somebody that I don't know and have no control over do that, or I do it myself. So the host addressing piece, I'm not going to spend a whole lot of time on this, but what I do want to talk about is unlike IPv4, where I think probably all of us, unless you get into some out-of-band management networks, those kind of things, we're all doing DHCP, right, for IP address assignment. V6 has got a couple of different modes. We'll talk a little bit more about the different modes and kind of what they're in. I know John's got a 10 talk that gets into this in a lot more detail than I intend to. But the key takeaway here is there's a method where I can go by and have my host get an IPv6 address without doing anything on my network. I don't have to turn on DHCP v6. It basically comes back from a new model on how we learn about our default gateway and get routing information. But I can do this self-assigned or the Slack address where we listen for router prefix announcements, and we'll derive an address based off of that. Now, in a lot of cases, we may be doing DHCP because I want to track, either from a security perspective, I need to keep track of who had what particular address at what time of day, those kind of things. And that's available here as well. But because of that, from a wireless perspective, this brings up a couple of different things. If you've worked with Aruba Wireless, we've done for a long time the option on the firewall to block who could be a DHCP server. So the idea is I want to make sure that I don't have somebody connecting to my network, accidentally being a rogue DHCP server, giving everybody 192.168.1 network addresses, and now they can't go anywhere because they're not addressed to talk to my gateway. In IPv6, with the router advertisements, this could absolutely happen. And so in some cases, these screenshots are probably hard to see in the back, I was noticing, but it is common, it is likely and it's common that your host machine, your phone, your laptop, whatever, will have more than one IP address. You'll at least have two in most cases if I've designed for IPv6. I'm going to have a link local address, and I'm going to have my global unicast address, my globally unambiguous address, so that I can talk to other places. But I might have other addresses. So this is one of the things that we'll look at, and one of the things that I want to get into as well as a concern. There, kind of as I mentioned, there are a couple of different address types. We talk about unique local addresses. Those were once a bigger component, there was the idea, kind of like with multicast, how I can scope and have a link local multicast, or I might have a multicast group that I want to have in a certain part of the company. With unique local addresses, that was the idea, is I could have some unique addresses that were within my site, but they couldn't route outside, but then I'd have a global unicast that could go outside. A lot of that's been, it made sense at the time when we were first starting this up, but we kind of moved away from it. But the biggest difference when you start looking at addresses then, when I want to talk to my default router, now my default router is not usually on the same subnet as what I would expect to see from an IPv4 world. So I use the example of a rogue DHCP server and somebody giving out another subnet telling me I'm 192.168.1, but I know my address is actually 155, 161, blah, blah, blah. In the IPv6 world, we do a lot of local management using those link local addresses. So the FE80, and then we'll derive the client ID part of that based off the interface, and that will be what I use for my next hop. So you'll see that at least those two sets of addresses, and then we go from there. There's a couple of different address types. This is kind of showing the range that we talk about. My loopback address, instead of being 127.0.0.1, is now /128. It's basically the loopback address. It's a 128-bit address, so the /128 means all bits are relative to the host, not the network, and that's actually it's :1/128 is where I get to. The FE80 is that link local that I talked about. So as I talk about address scarcity or address abundance, when you look at the range that we'll use for all of our allocations today, it's that second one from the bottom, the 2000:/3. So we're taking the first 3 bits, saying those are network, and then all the other networks that get derived that are being assigned right now are coming out of that range. So if I go to somebody like Hurricane Electric, which is where I get my IPv6 connectivity from, right now they'll assign you an entire /48. And so I've got a tunnel to the house, I've got a /48. The whole goal is this makes subnetting very simple. I can start to be a bit more logical about what nibbles in the IPv6 address do I want to use to document or assign this is a site, or this is a particular set of devices that I'm going to have. This is my IoT, and this is my IPTV network, and this is my wireless network, et cetera. We can break it out that way, but that's all coming out of a small little piece. Most of the time from a host perspective, I'm going to see network addresses of /64. And there's several different reasons for that, but it nicely fits my 48-bit MAC address inside that host client, so that might be one way that we come up with it and go from there. But there are the other types. There's the FE00 for the multicast addresses, the FE80 that I mentioned, and then the unique local address, the FC00 that I mentioned, is really kind of not used at this point. From a notation perspective, I like this as it reminds me of the old IPX days when I could come up with kind of names and encrypt it, or not encrypt, but write different things. You'd have your bad dad IPX network or whatever, since it's hex, and I can get away with a couple of characters and try to see just how creative I can be with hex. Because of the number of spaces, there are some different abbreviations that we can get into. If there are segments that are all zeros, we can omit them. I can do that once, so you can get away with a : When I look at the top address, the 2620:11D: 6000F, et cetera, those middle 4 groupings that are all zeros, I could document this either by truncating them, so I don't have to show a leading 0, and that's what the second row is showing. I could, instead of going with 000:0000:0000, I can just truncate those down to a single 0, or I can take that step one further and remove all of those 0 ranges and just do it as a : But like I said, I can only do that once because we have to know how many places on either side do I still have of the address. All right, so what's the big deal? So with V6, things changed a bit. Instead of using broadcasts, like I mentioned, broadcasts have gone away, but we still do a lot of the same functionality. So instead of having an ARP where in an IPv4 world, if I want to know what's the physical MAC address of my default gateway, I want to talk to somebody off network, I'm going to send an ARP. I'll ask who has this IP address. I'll get a response back, and now I know can build the ARP table or my neighbor table and go from there. In IPv6, we do that a little different. We're doing this multicast based, so there's more of an advertisement that here I am and here are the addresses that I use. Here are the things that I want to talk to. And it's a different traffic flow, but it also has different implications, right? So in a lot of cases, how many people are doing on their wireless network kind of this concept of VLAN pooling, where I'll have a bunch of VLANs, say a bunch of /24s, and my wireless users just kind of get spread across the 24s. Jake's shaking his head. He doesn't like that. I don't like it either. So the great thing, or the problem potentially, is that in a multicast environment, you remember when we're doing wireless, the whole notion of my VLAN IDs and my trunking and whatnot on the wired side doesn't really carry over to the wireless side. So if I've got a controller or I've got an access point that's on a .1Q trunk, and there's 100 VLANs behind it, and I'm saying, great, I'm going to take all my wireless users and we're going to spread you across these four different VLANs. Well, as these neighbor discovery, these neighbor advertisements are coming back in, how do I make sure, since we're all on the same VLAN, that Sam only gets the one relative to the VLAN that he's connected to, and Jake only gets the one relative to the VLAN that he's connected to? Well, there's not really a method for that, right? Because if I'm doing WPA2 or I'm doing WPA3 where we've got encryption, it's still a group key for any of the broadcast multicast stuff. So typically, until we get into finding solutions for that, and most vendors have got that at this point, but that was the problem, was there was the potential that I'd have multicast leakage where I would see multicast destined for another VLAN, but I'm seeing them. And we're using link local, so I can actually talk to that range because it's an FE80, so it's a valid address, it looks like to me. And so potentially, we could start to see my interface list now populating and saying, I have a whole bunch more interfaces, and we go from there. So the major changes, V6 is using multicast instead of broadcast. So we talk about route discovery. How does this go? So again, I kind of mentioned we get into different pieces now where the router is advertising saying, hey, I'm a router. So the interesting thing about DHCP v6 is one of the pieces that we don't give out anymore is a default gateway. So in IPv4, usually that's one of the first elements that I'm putting in is here's your range and here's your default gateway and maybe some DNS information, those kind of things. In IPv6, DHCP doesn't do default gateway. The client device is going to learn default gateway based off these router advertisements, and then from a configuration perspective, I can set different priorities and those kind of things. And the goal was, maybe I don't need VRP or HSRP, those kind of things to find or make sure that I always have a gateway available. I'll let the gateways kind of do this dynamically. So we have that piece. The RAs are going to come out. Routers will send those out periodically. The client device can also do a router solicitation. So when I first boot up, I can either wait for the router to send out a router advertisement, or I can ask for one. And we can see in here, and like I said, I apologize, these are going to be kind of eye charts, but we'll make sure that gets out. You can see the different fields in there where we're specifying, here's the priority, here's the prefix. And in this router discovery, either the RA or the response to the router solicitation, we'll tell the client device, are you going to basically use Slack to build your own address, or are you going to talk DHCP v6 and get some or all of your information from there? Let's see, so we're using the link local, using neighbor discovery to find out what network we're on, and then using the same process, this ICMP v6 process for discovering our neighbors, figuring out who has, via these multicast, who is a particular network or host address, getting the physical layer so that we can go back and talk to them. All right, so from a client addressing perspective, I mentioned that already. You come through, we've got a couple of different modes. I can either go full static, typically what I would do in a lab environment in a lot of cases. We've got the AutoMagic, which is, again, your IP, or your DHCP v6, where I'm going to do everything back from a controller. We'll call this stateful. And then there's some modes that are in the middle where I might use DHCP v6 for some information, or we could go full Slack on everything else. All right, so the biggest question, if I'm looking at IPv6 for the first time, which mode do I want to use for address allocation? And again, I'm not going to go too much into this part just due to time, but the whole idea is, one thing we have to consider is different clients support different standards. So particularly if I'm in the Google world, Androids, Chromecast, those kind of things, they say no to DHCP v6. So as soon as we're right off, if you're at Atmosphere, I can't do DHCP v6 and expect all my clients to work because somebody's going to show up with an Android device, hopefully. And so these are one of the things to consider. You get into different device types. iOS, from particular releases above, will support stateful DHCP, stateless DHCP. So the stateless is where I'm still doing Slack to get an address, but I'm using DHCP to get some other options, and kind of go on from there. It's a point that we want to know about, and then to the security side, this is a point where I need to make sure that if I'm intending to put IPv6 on the network, I know what I'm doing, I know what I intend to do, so that we can monitor and make sure that somebody else isn't on the backside, one of my users, manipulating the system and sending their own RAs or sending their own DHCP v6 info, those kind of things. So best practices. Again, as we talk through it, the feature matrix here isn't important for this slide deck. The main point was, as you're looking at IPv6, it's understanding, talking through the client side, the client devices will have different levels of IPv6 support. Your infrastructure gear, likewise, will have different versions of IPv6 support. So if I want to do IPv6, what does that mean for me? We were talking, Marcus and I were talking earlier this morning about a customer that wanted to go all IPv6 on the management network. And so these things start to be important. Most vendors came back and said, well, we support IPv6. I can do that checkbox. Federal government wants to make sure that everything we buy supports IPv6. So yes, I can allow an IPv6 client to connect to the network. Check the box, I'm IPv6 compliant. Great, I need my AP to talk to a controller and I have an IPv6 network. No, maybe we can't do that yet. So it's understanding what does my vendor support, and are they in line with what we need to do. The other piece, so I talked about having different addresses. A lot of my networking equipment might have table scale limitations, right? I can support an ARP table of a certain size. I can have so many route entries, those kind of things. Well, if I've got a firewall or I have my WLAN controllers come back to an aggregation switch, I need to be aware of what are the table sizes of that aggregation switch that my controllers are connected into. Because before, I might have had, in this picture, I had 1,000 clients connected to my wireless network. And so I think, great, my aggregation switch, yeah, I can do a MAC table of 1,000. That's pretty common stakes for just about anybody's stuff. But as soon as I turn on IPv6, and now I'm getting multiple addresses, now my table isn't 1,000 hosts connected with one IP address. I'm multi-protocol. I have 1,000 IPv4 addresses, and I might have 3 IPv6 addresses, so now I have a table size of 4,000. 4,000 probably isn't that big of a deal, but as you scale this up, and particularly as we get into some of the higher ed scale where I've got 40,000 users connected to the network, take that, multiply it by 3 addresses, that starts to get rather large, and we need to consider that. The other piece is kind of as I mentioned, so this is just a slide showing, again, in the user table looking at, for a particular MAC address, I'm seeing that we've got 3 different addresses for a given wireless client. The other piece is that I mentioned, the VLAN pooling concept. So the idea was doing larger VLANs depending on your background. If you grew up where I did, where we bought in on the route mentality, I didn't want to have an IP subnet that was larger than a /24. There would be too much broadcast, too much multicast, and that was just going to crash my wired network. So we keep them small, and if I have a large number of users that need to get on wireless, I'll just throw more VLANs at it, and that'll scale out. What we see with V6 is that doesn't. And most of the wireless controller vendors these days, we've got the broadcast multicast mitigation controls in place, so there's really no harm in going, larger subnets, even a /16. We can go back and make sure, since we know where the where the wireless users are, if one device tries to ARP for another, I can catch that, I can convert it to a unicast, make sure it goes where it needs to, and I don't have this broadcast multicast flood. So we want to do that, and then also to avoid the multicast leakage issues that I was talking about earlier. This is a screenshot just trying to show quickly. On the left-hand side, this is what I would expect on a normal IPv6 enabled network. I've got 2 addresses. On the right-hand side, this is where I'm starting to get some bleed from too many multicast packets off other networks that are coming over. We did this just to kind of prove a point on that, so that's to be concerned about. There are lots of white papers out on Client considerations, again, kind of getting into the 10 talk that'll come up tomorrow, I believe it is, talking some of the specifics on this piece, so definitely stay tuned for that. I kept my Q&A slide in just to have a Q&A slide. I'm not actually doing any questions. There's a couple of resources that are worth looking at. If you're into podcasts, as Sam mentioned, there's the Packet Pushers, the IPv6 Buzz podcast has got a lot of great information. The last couple of podcasts that came up were wireless specific. Or related to why wireless could be a good place to start your migration into supporting IPv6. Infoblox also has an IPv6 Center of Excellence, so there's a lot of good blog posts there on addressing strategies, how I might want to address my network, get address space, those kind of things. And of course, the Atmosphere, the Airheads blog from Aruba has a lot of good information there as well. And that's all I've got.